So we're going to make sure we're good with growth and decay, and then we're moving on to something new today. So the population of New York City increased. That's where it started in 1990. I'm going to keep reading. I hope we're all paying attention. The annual rate of increase was 0.9%. Write an equation for the population, y'all. The worksheet says growth and decay. So what kind of equation do we need to write? Exponential, because it says exponential growth and decay. And what do we know all exponential equations should look like? A times B, good job, Gwyneth, raised to the X. My boys over there, y'all good? Y'all knew that, why ain't y'all answering? Participate so you can get your extra credit. A times B to the X, are you paying attention? You know that, okay. So you know how to start. So y'all, what does the A stand for? My Zoom girls, y'all can answer too. What's the A stand for?
Initial.
The initial, good. Jasmine, can you tell me how many people we started with? What's my initial number of people? Tyree, make sure you're paying attention, bud.
7,322,564.
7,322,564. Excellent job, babe. That's your initial number of people. It says it increased from that to something else. So that's the initial. That's where you start. I'm a little concerned because I had some of y'all trying to say that 1990 or 2000 were the initials. Not the years. How many people did you start with? Okay. Any questions on finding the initial? Are you sure? You got 3 of these on your test. That's why I'm being hard on y'all. Like, you need to know how to do this. Now, how do we find the factor, the number that goes in parentheses? How do I find that? Did I give you a factor? Did I tell you what we were multiplying by each time? No, what did I give you? Oh, there we go. Who said that? Was that Sean? Sean, extra credit. Good job. I gave you a rate, which Gwyneth also said is a percent. So everybody look, if I give you a percentage, what do you have to do to that to figure out the factor? What's your first step? Change it to a decimal. We talked about this yesterday, and there was tutoring on this yesterday. If you have 0.9 and the 0 was in front of it, let me write it right first, that would help. 0.9%, when you change it to a decimal, are you making it bigger or smaller? Smaller. So Jay, I'm going to move my decimal how many places to the left? 2, because there's 2 zeros in 100. So you can take that decimal and slide it 2 places. 1 place, 2 place. It should be out here. What do you put in the gap? A 0. So does everybody agree that the rate as a decimal is 0.009? Y'all okay with that? You should know how to change percents to decimals by now. We've been practicing it for 3 days now. This is the 3rd day. So remember, you got to change it to a decimal first. Now, some of y'all put 0.009 in the parentheses. That's not the factor. That's just what we get when we change the rate to a decimal. How do you find the factor if it's growing? Because it says increase. Add it to 1. So y'all, you should have done 1 plus 0.009, and that gives you 1.009. That's your factor. Because remember, if it's growth, it should be bigger than 1. So we're going to add it to 1. And then what do we always raise it to? X. You didn't need to put anything in for X because it just said to write an equation. So this would be the equation. That's the answer to the first part. So I'm going to pause for a second and see what questions we have, because a lot of y'all said you didn't know how to do that part. Use the equation, which we already wrote. That was the hard part, to predict the population in 2010. So let me ask y'all a question. What year did we start measuring the population in? 1990. There y'all go. There's my kids. All right, here we go. If we start in 1990 and it's now 2010, how many years has it been? Somebody said it, I thought. I heard 10 and I heard 40, and those are not right. What'd you say? 20. Y'all, 1990, 91, 92, 93, 94, 95, 96, 97, 98, 99, 2000. 2001, 2, 3, 4, 5, 6, 7, 8, 9. 2010, that's 20 years. Where do I put the 20? In for the X. Good, y'all. So did y'all get 7,322,564 times 1.009 raised to the 20? Okay, where did y'all go to type that in at? Into Desmos. Good. All right, so I'm going to switch my screen. People at home, do y'all have that?
Yep.
Okay. Jazz, you getting all the extra credit, girl, for answering me. So y'all look, let's go to Desmos. Do y'all have that written down? Okay. So we're going to type it in Desmos. Maybe. Mine will load. There we go. All right. 7,322,564 times 1.009 raised to the 20. Ooh, that's a lot of people. So 20 years later, how many people do we have? 8,759,000. Good. Ooh, that's not what I got. Keep going. 1,640. Yes, good, Gwyneth. Y'all look, you cannot have 0.8 of a person. So take the whole number, look at the butt. I said that to my math 2 kids today, and they got very embarrassed. I was like, why are y'all embarrassed? Look back at it. Is 8 a big butt or a small butt? Big, so it's going to round it up. So do y'all agree the answer would be 8,759,644. Nope, 645, because you cannot have 0.8 of a person. You round it up. I also, y'all listen to what my math 2 kids said. One of them said, what if they're missing an arm? I was like, how are you sitting in this honors class right now? Yeah, they're still a whole person. They're just missing an arm. And that was a wild question to me. I was like, no. Good, we're going to record this. 20,700 is the initial. Very good. Okay, did I give you the factor? No, Tyree, you're watching, right, baby? I gave you a percentage. Can you just plug that percentage into the equation? No, a percent is not a number. You're going to have to change it to a decimal. So how do we change a percent to a decimal? 2 decimal places to the left, because you're making it smaller. So I'm going to change the color. We're going to move it. It's behind the 11 because we can't see it, right? So move it 2 places to the left. So do y'all agree that would be 0.11? And then look, it says the value of the car depreciates. So that means the car's value is going up or down? Down. So to figure out the factor, you have to do 1 minus 0.11. Because it starts off at a whole 1. It starts off at 100%. So what is 1 minus 0.11? Think about 100% minus 11%. What would that be? 89. So that this factor, y'all, should be 0.89. And then it says after 11 years, so you're going to raise it to the 11th. This is what you should have typed into Desmos. Does that help? It'll be good. If you had the 2 letters, D for decimal and P for percent, and you put them in alphabetical order, which one would come first on the left? D. So if you're trying to make a decimal, you move it to the left. If you're trying to make a percent, you're going to move it to the right. You can write that. You can be even cornier and think of Dr. Pepper. Think of something that helps you remember decimals left, percentage right, okay? So we're going to move it 2 places to the left. 1, 2. So what goes in this gap right here? A 0. And then look, if it's gaining interest, that means your money is going up, right? So you're supposed to do 1 plus 0.065, which would just be what? Yeah, 1.065. Good job, y'all. And then we raise it to how many years? 14. This is what you should have typed into Desmos. Yeah. The good news or the gooder news? The good news, this is your last topic in this unit. We're about done with exponents. So tomorrow you're going to do a lab on everything from this unit. It's only 10 questions. Won't take you long. You'll do it after you take your vocab quiz. And then Monday you're going to work on your test review at home because it's a virtual day. Then Tuesday we'll go over the test review, and Wednesday you'll take your test. Okay? So 28, last lesson. So the gooder news is this is kind of already something that you should know how to do. So I'm going to pause while y'all get this copied down. All right, so let's review really quick. This is review. Can somebody tell me, and I really hope you can, or I'm going to be upset because it's one of your vocab cards for this unit. What does the word regression mean? What is regression? Line of best fit. Now listen, good. Don't write that. Let's talk about it. It's the process of finding, I'm going to put this in air quotes. Are we all looking? The line of best fit. Are we doing linear functions anymore? No. What kind of functions are we dealing with now? Exponential. So this is going to be finding the exponential function of best fit. So finding the exponential equation of best fit. Finding the exponential equation of best fit. You good, babe? You can take a picture if you need to. You can also come sit over here if you want, since Kiara's not here. Finding the exponential equation of best fit. Now, let's think about it. When we did lines of best fit, y'all do not have to write this. I'm just doing it for you to look at, okay? So everybody look. When we did lines of best fit, don't write it, just watch. Do y'all agree that this is what our scatter plots looked like? Something like that, right? Curtis, you don't need to write this, babe. So when we did lines of best fit, the points on the scatter plot looked like that. They kind of looked like they went in a straight line, right? What do y'all think the points on these scatter plots for exponential are going to look like? Not all over the place. What kind of shape do exponential graphs make? A J. Good, Gwyneth. So y'all remember, they're going to shoot up really, really fast. Like this, and they're going to end up all the way up there probably. You see how it curves? So we're finding the curve of best fit when we do exponential regression. Does that make sense? Your scatter plots, the points should not be going in a straight line this time. If they do, then hello, it's linear. If they're curving and shooting up, it's going to be exponential. Do we understand that? Okay. So your steps for exponential regression are really basically the same as linear. Just one thing is going to change. Where is my black marker? There it is. So let's write our steps. And then we're going to do a couple of examples, and then I'm going to let y'all scoot. So what's up, baby? You can, or you can write it in your notebook. Doesn't matter to me. Uh-huh. All right, so your first step, who remembers when we did linear, what we had to go put in Desmos very first? The table. Good, Gwyneth. Hang on, I want to get everybody's attention. Does everybody see over there right beside Sean, it says linear regression, and then there are steps. We're doing the same thing. So step one, use the plus button to add a new table. I do want you to write them because some of y'all didn't know them the first time, so maybe it'll click this time. Click plus and add your table. Once you put the X's and Y's in your table, do I need to write that part this time? I feel like y'all know once we add the table, you got to go put the numbers into the table, right? I don't feel like I need to write that. Okay, I didn't think so. I just wanted to make sure. So after you put your numbers in the table, look at that purple step by Sean. You click the little magnifying glass and it'll take you to all the points, right? All right, so that's step 2. And I'm going to draw what the little magnifying glass looks like. It looks like this. Kind of. Y'all know I'm not a good artist. So click the magnifying glass to zoom fit your graph. You do that after you type your table numbers in. All right, once you're done writing the purple, everybody look at the poster. What's it say in orange? Y1 squiggle mx1 plus b is for linear. What are we going to type in? What do you think? Okay, what she said. Y'all are funny. Okay, so look, they're saying in class, my people online, click in a new box and type the exponential equation, which is, I'm gonna make sure we all remember. Let's see, I got a marker. Let's write it in a marker so it sticks with y'all. Y1 squiggle. A times B raised to the x1. I wrote it nice and big so we can all see it. Curtis, you good with this, bud? Y1 squiggle. So remember, somebody help us out. Let's see if y'all remember. Why does Desmos use Y1 and X1? Do y'all remember? So in the table, everybody listen, when you're adding tables in Desmos, because I didn't hear anybody say this, so I want to make sure we all understand. When you're adding tables in Desmos, you can add up to like 10 different tables. We're not doing that. We're just going to have one table, but it's going to call them X1 and Y1 because you can add more, okay? When you get to math 3, I think this is where Jay was going. When you get to math 3, you will add more than one table, and you'll start comparing them at the same time. So in math 3, one of your equations, you'll use Y1 and X1, and then in the other one, you'll use, what do you think? Y2 and X2, because it's the second equation. Does that make sense? So you're going to use Y1 and X1 still. Who can tell me why we use the squiggly sign? They said it don't let you put the equal sign. Why does it not let you put the equal sign? Let me pull this. Let's look at this picture. Do you think a J would hit every single one of those points? No, I can show you that it won't. I'm going to try to hit them all, but there's no way it's going to kind of go in between them, right? So it's not going to be equal because it's not going to touch all the points. What's that squiggle mean? Starts with an A. Approximate. There you go. So you're estimating, you're approximating what the curve would look like because it's not going to be able to hit every point. So remember, that's why it's a squiggle. I'm a little worried we don't remember that from 2 units ago. Are we okay? All right, so we're going to add our table. We're going to click the magnifying glass to see our points, and then we're going to do the Y1 squiggle. It's not MX1 plus B. My kids last semester did not pay attention. I want you to listen. My kids last semester, it would say exponential, and they were typing in MX plus B. That's not exponential. So the whole thing's automatically wrong. I can't give you credit. So make sure you're reading your problems, and we're doing exponential, okay? So now I'm going to flip over to this example sheet. If you are at home watching this and you could not print the example sheet, that's totally fine. This is what I want you to do. Just copy down the table. You don't need to write the words, just copy the table. Nope, because y'all already know to do that, I think. Y'all said you didn't need me to write it. So my people at home, you're copying the table. My people in class, while they're copying, I need you to read the problem, okay? People in class, what does the first sentence say down here? Right, good. Sean, y'all with me, babe? Everybody look, Tyree, you with me? Write an exponential equation to model the data. So where am I gonna go put this table? In Decimos, is what Curtis said. And then we're gonna find, everybody listen, we're gonna find the exponential equation. If you type in mx plus b, it's wrong. I just wanna make sure we all understand that because my kids last semester did that and I didn't get it. I'm gonna pause for a second. Okay, so what's my first step to find the exponential equation? What do I gotta go put in the Desmos? The table. So everybody click the plus sign in the top left. Click it. What are you adding? A table. And then I need you to go put your data in. And please make sure you type it in right or you're not going to get the right answer. And I'm saying that to myself too because y'all know I type stuff in wrong. The ADHD, 1650 and 3000. And if you finish early, if you could check behind me, that would be awesome. Here, Jay. She's big. All right, the table is in. What's step 2? Look in your notebook. What's step 2? Click the Zoom, so I want everybody to watch. Are we all looking at my screen? When I click the Zoom, it takes me to all of those points, and y'all, what shape are those points making? A J. It is not mx plus b. It's shooting off like a J shape. So that means it's exponential. So step 3, you click in a new box. And what do I type in to find exponential? Y1 squiggle. I heard A times B, which was good, raised to what? X1. Good job, y'all. The squiggle is above, it's beside the 1. You see it? You're welcome. Now listen, there's one thing I forgot to write down. Y'all will have to forgive me. We'll write it down in a second. It is extremely important. Give me 1 second. I'm going to talk to y'all. Extremely important. Like, this is the most important thing I'm showing you today. Is everybody listening? Do y'all see this box that says log mode? You have to click that. I'm going to show you why. Do y'all see how this is not touching those first couple of points? It's because you don't have log mode on, okay? So what log mode does, log mode makes sure this does not go into the negatives. So it'll flatten it out more. So let me ask y'all a question. Are we ever supposed to have negatives with exponents? No, because in the real world, we can't have stuff negative time. So I need y'all to click this log mode button, and it's going to flatten it out. So everybody click log mode. Should flatten it out. And it does change your number. So I want you to watch really quick. If I uncheck it, are y'all looking at my numbers? Let me move them up because y'all can't see them all. Y'all can see them now. You see my A and my B? Everybody watch. When I don't have it checked, do you see how they're different? If you don't click log mode, it's going to be wrong. So you got to click log mode. So y'all, what is our equation they gave us? And I'm good with y'all just rounding to 2 decimals. I know it says thousandth, but we're just going to do 2. So what's my equation? Y equals what? What's the A value? 215 point what? Okay, be careful. Look at your butt. My math 2 kids were pissed at me. They were so embarrassed. 98. Look back at it. It's a 3. That's a small booty. We're not going to take a double take. So do y'all agree it's 215.98? That's the A. Times, what's the B value? You can see it on your screen. Round it though. 1.6, what? On your screen? Okay, I'll come look in 1 second. 1.65, good. Raised to the X. That is the equation that you should get. Just to remember, y'all, it's an exponential equation. So when you do an exponential equation, it should be y equals a times b to the x. So all I did was put the a and the b in that they gave me to make the equation.
Oh.
See it?
Okay. Yeah.
All right, so
What
y'all,
do you do again?
huh?
What do you round to again?
2 decimal places is fine. That's what Delphin's going to ask you to do is 1 or 2. So 2 is good for now. We'll do 1 on the next one, okay? Everybody paying attention? All right, so look, let's read what the question is actually asking now. So I'm going to slide this for a second. Everybody look, I'm zooming in right here. Assuming this continues, use the equation to estimate the number of bacteria at the end of 7 hours. I'm going to show you 2 ways to do this. Did everybody hear me say that? I don't have all eyeballs, so I have no idea if all of y'all are paying attention. Make sure that's up, baby. 7 hours. Who thinks they could tell me one way we could do this problem? Very good. Were y'all able to hear her at home? Probably not. So she said the first way you could do it is the way we've been doing it. Jay, y'all watching, babe? You can type into Desmos 215.98 times 1.65 raised to the 7. That's the first way you can do it. Now, can I keep it hot with y'all? I really hope we're all listening. Curtis, you listening? Your phone is up, right? Okay, just make sure. You kept looking down. I gotta watch my Josh too now. Everybody listen. That's the longer way to do it. Can I show you a faster way? I don't care which way you pick what works for you, but I'm gonna show you a faster way. They said 7 hours, right? Hello? 7 hours? Okay, look in your table. Hours, is that the X or the Y? X. So y'all look, let's see if y'all remember this from linear. You can go type in a new box. Y'all can see my box down here. X equals 7. I'm gonna make this bigger so y'all can see it. And then I'll move it again. So I wanna make sure we're all watching. So I'm gonna exit this again, everybody watch. You can type in a new box. I'm gonna do it one more time. X, because y'all said the hours was X, equals 7. Do you see how it graphed another line? You can scroll and see where these cross, click it, and it'll tell you how many bacteria there are after 7 hours. Do y'all remember doing this when we did linear? Yeah, okay, some of them are saying yeah. It should have, so I'll come check yours in a second. Everybody look, if you typed in X equals 7, did yours do what mine did? If not, I'll come help you in a second. But look, how many bacteria did we have after 7 hours? 7,200. Okay, let's think about it. Let's think about it. Can you have 0.5 or 0.6 or 0.9 of a bacteria? No. So look at this 59. Look behind it. 0.6. Is that a big butt or a small butt? Big. They said big. So what does 59 round up to? 60. So y'all, do y'all agree there are 7,260 bacteria after 7 hours? That's the way I recommend doing it because it's going to be less work and it'll give you an exact answer. Because when you wrote your equation, you rounded it. Okay? So I would prefer you typing in X equals 7 and find where they cross. So my girls at home, y'all do need to write the table, but I'm okay if you want to copy it down later and go ahead and just try it with us, okay? All right, we're going to add a new table. Did y'all see how I cleared everything else out? I would clear everything else out so that you don't confuse yourself. So start again. We're going to add a new table. Tyree, are you doing this with me in Desmos? Okay, can you add a table and do this one with us? So click the plus button, add a table, and then type in your data. 1. Be careful because the next number is not 2, it's 3. 3, 4, and that's a 6. 1,000. Don't put the commas either. If it's 1,000, remember, don't put a comma in. Desmos is picky about that kind of stuff. 45. What do you do after you have your table in? What's step 2? Oh, Lord Jesus. No, not, oh, I know he didn't just say MX plus B. Good, good. That boy said MX plus B. Hit the Zoom button. You're going to confuse my people watching this later. Watch, they're going to do MX plus B. That boy said, I'm sorry. Now, look, when you hit the Zoom button, y'all, do y'all agree? I know they're smaller numbers this time. That's not a bad thing. But do y'all agree if we tried to connect these, it's still a J shape? Just this time, it's going down. I'm about to relate it to what we did yesterday. If it's going down, that means it's decay. It doesn't mean it's negative. It means it's decay. Very good. So my girls at home, how do we find our equation? What do I type in this box? Oh, I said people at home. It's okay. Y'all go ahead and do it. If you know it, do it. Girls at home, what do I do?
Y1 squiggly line.
Uh-huh.
A times B.
A times B.
X1.
Raised to the X.
Raised to the X1.
Good. And Jazz, what do I have to click, babe?
Oh, log mode.
Log mode. Everybody click log mode. If you don't click log mode, it's wrong. I don't really have any other way to say it. Like, you got to click it. I'll think of a funny way to help you remember it. Log mode. Click log mode. So it says on our worksheet, I'm going to move this so y'all can see it. It says write an exponential regression equation. Now, I'm going to ignore what they told y'all to round to, because most of the time in Delta Math, I hope we're listening, it tells you 1 or 2 decimal places. So let's practice 1. We did 2 last time. So let's practice 1 decimal place. So look, I'm going to draw up here. Go to 1 number behind the decimal. It's a 2. Look behind it. I see an 8. Is that a big butt or a small butt? Big. So what's that 2 going to round up to? Very good, y'all. So do y'all agree it's y equals, remember we're doing a times b to the x. So my a is 1018.3, 1018.3. All right. Does anybody not see how I got that? 1018.3, you go, babe? Okay, look at your B. 1 decimal place. It's a 5. Look behind it. It's a 9. That's a big butt. So Gwyneth, what does it round up to? 0.6. 0.6. And we're going to raise it to the x. So there's your equation. So I'm going to pause for a second. What questions do we have on the equation? Okay, so let's look at what they asked. Use the equation. Predict how many coins would be returned after the 8th trial. Let's do it the way I recommended. So y'all look, I gave you the trial number was 8, right? Okay, look in your table. The trial is the x. So what did I tell you x equals? 8. Very good. So everybody look, we're going to go in Desmos. I'm going to make it big for y'all again. We're going to type in a new box, x equals 8. Let me move my Zoom people so we can see. So if you type in x equals 8, do y'all see where I did that? Okay, I can't see it on mine, so all you got to do, babies, is zoom out. That's fine. So when x equals 8, does everybody agree it looks like it crosses right here? So if you click that on the 8th trial, how many coins are returned? Good. Everybody listen. You cannot have 0.4 of a coin. What you going to do, cut it in half? That don't make no sense. Scissors are not strong enough to cut coins. So it's not 16.4. It's how many coins? Just 16. So on my paper, I'm going to write 16. He said because it's a little butt. He's right. Do we have any questions for me before we go do our classwork homework? I think it's only 4 questions. It's 4 of these to try in Delta Math.
Is it okay if the line is red?
If it's okay, yeah, Desmos color code stuff based on, I don't even know how they do it, to be honest, but they'll always use a different color. So your colors just might be different than mine.
Okay.
That's totally fine though. We're just focused on the numbers. Do y'all have any questions? All right, go do your classwork so you don't have homework. Make sure I get my cards. I'm letting you know now. Every time you don't turn in cards, I send an email. I'm calling parents tomorrow because you not making 8 vocab cards when you had over a week to do it is ridiculous. Do we understand? All right, and it's not to be a butthole, it's to hold you accountable. Because I don't want nobody failing Math 1 because they couldn't make some daggone vocab cards. Do we understand?